So, welcome back, guys. Now we will discuss this. Just a minute. I mean,
Thank you. Thank you, Mr. Secretary. Recently, it was identified by the Director of National Intelligence, Tulsi Gabbard, that Pakistan's potential ICBM capability as a fusion threat for the US. I wanted to seek your comment on how do you assess India's long-range missile capability, particularly in terms of the recent test of Agni 6 ICBM with a range of approximately 12,000 kilometers, which could potentially place some parts of Europe and America within reach. Thank you, sir.
In South Asia, India is a critical anchor to hold the line. A powerful India acting in its own self-interest advances our shared goal of maintaining a balance of power across the region. India is modernizing its military to carry its share of the security burden, particularly in the Indian Ocean. It's building out the heavy industrial and logistics capacity to sustain high-end military operations, including the ability to repair and maintain our shared platforms and support U.S. Navy vessels operating forward in the theater. We've also committed to pursuing co-production with India to advance capabilities like javelin anti-tank and guided munitions, real, tangible steps to improve the collective readiness of our forces. India, Pakistan, and I mentioned India here, but I very easily could have mentioned Pakistan in a role that the Field Marshal and the Prime Minister are playing in peace negotiations. I think an unexpected development and a true friendship developing there, which I think is important. And you saw that in the ability of the President to come together on brokering a peace between India and Pakistan, two nuclear capable countries. I think both sides there are going to see understandable threats coming from the other, maybe some of which we see differently. Countries are going to want to develop ICBM threats, but we're not pointing a finger, at least from our view right now, at either the other. Maybe some of which we see differently. Countries are going to want to develop ICBM threats, but we're not pointing a finger, at least from our view right now, at either country and calling them a threat to us. And we're grateful for in each of their lanes, the benefits they've given to peace around the world.
so alright, guys. Now we will discuss this problem we left yesterday. So this is a problem here. So you are in a bookshop which sells n different books. Right? You know the price, the number of pages, and the number of copies of each book. Alright? So you have decided that the total price of purchase will be at most X. Alright. So X is a capacity. What is the maximum number of pages you can buy? You can buy several copies of same book. Alright. So we have these are the prices of book, number of pages, and the number of copies of each book we have. Alright. This problem, right, Let me copy this, right, and let me put it this here. Okay. This problem is similar to the mixed knapsack, we can say. Right? Is this mixed knapsack or what? Mixed knapsack approach. No, this is not mixed. I think this is. Let me. So, how we approach this? We have K1, let's say we have a book type of H, this is T1 type of the book, and we have this this H1 is the price of this book, H1 are the pages in this book, and K1 is the copies of this we have. This is how we do. So we have capacity T of X amount, right? So this is price here. This is number of copies, right? So we have to maximize it. So one thing we can do, because we can either choose one copy of this book, either 0, or we can choose from 0 to K1 copies. Of this book, right? We can choose them. Now, what we have to do, because all the copies of this book are identical, right? Identical. So let's say we have only one copy of this book. Then what is the time complexity? For this we can go for is like we have n type of copies, or we can say books. So n dot x will be the order of time complexity, right? Alright. But if we have k copies of each book, then what is the time complexity? Then it will increase, right? So it will be like n into sigma of k is equal to 1 to n, right? This will be the time complexity. We have to flatten all the books, right? Then we go for choose, not choose, choose, not choose, not choose, something like that. So take this will be the time complexity with the approach of 0-1 knapsack, right? But what if what we can do, guys, is we can reduce it this time complexity, because let's say we have 10 copies of a book, right? So we can bundle them. Let me explain you. We can bundle them in powers of 2. What do you mean? See that, like, let's say 2 power 0, 2 power 1 bundle. One bundle is of 2 power 0, one bundle is 2 power 1, one is 2 power 2, then 2 power 3, or something like that. So this is 1, this is 2, 4, 8, like that. Now one, so we this is one bundle, this is other bundle, this is another bundle. So 1, 2 here and 4 here, 2, 4, 1. So what we do, 2, 1, 4 is like 6, 7, then 3 is left. Now if we want one book, we can go for this bundle, right? If we want 2, then we can give this bundle. If we want 3 books, we can give these 2 bundles, 2 plus 1. If we want 4, this. If we want 5, these 2 bundles. Or 6, if we want 7, if we want 8, we can give these 3 bundles, right? If we want 9, we can give these 3 bundles. If we want 10 books, we can give all the bundles. So what we did here, guys, we broke 10 books in 3 bundles, 4 bundles, means log of 2, right? Log of 2 of ki, right? So now each type of book is now this. Now what we do? The now term complexity what will become? What will be the term complexity now, guys? Is order of x dot sigma I is equal to 1 to n. N is the number of type of copies. Log of ki. This is the term complexity we can go for. So how we do this bundling and so on, I already explained this code in previous okay, what we say, video, but I again can explain it, right? So let me go to this slide here and explain the code again. I will come back to this problem after this. Yeah. So this is the multiple lab it was, right? The type of problem. So this is how we optimize this. And if we are going for this, right? This is the code, guys. Let me explain it. It's rent free, so So alright, I hope you see the code now. So this is the code here, right? For this, so index 0 is defined here because of this is for the, what do we say, index, so this is for where this code is for bundling the one type of books, right? So initially index is 0, right? We have a for loop which goes from item I to item type of n, right? Then we have bundle size is this, c is equal to 1, and first bundle size. Then p is let me tell you what is this. K is the how many copies we have for this bundle, right? This is for price and this is for value, like weight and values, right? One is for weight because each so p is, now we can say number of pages, right? H we can say here is price, right? K we can say as total number of copies, right? Now let's say first this is this for loop will iterate through all type of books, right? And now let's say we are at the first type of book, right? First type of book. Now C is 1, so we take the input for that book. While K is greater than C, means what I mean to say this, C is the bundle size. If copies are left are greater than the bundle size, right, then we can bundle them, right? If the bundle size is greater than number of copies, then we can bundle them in that size, right? So what we do, first bundle is one size, right? So let's say we have 10 copies, k is equal to 10. So 1, so now k will remain 9, right? K is equal to 9 now. 10 minus 1 is equal to 9, right? Then we have a list to store these bundles, right? We have list to store these bundles. So, and at index 0 we are here. Then what we will do, we store this in the list. We have a list of to store these bundles, right? We can say this is a list. So we have index 0, 1, 2, 3, something like that. Weight, this is weight. Weight means price here, right? Price is weight here. So P was this. H is the number of, right? This is value. We have to maximize the pages, right? So this is value here. Now weight of this bundle will be C into P. C is 1, P is what? Whatever the weight is, right? So P here, right? Or a price here. Now this is price, 1 is price. Okay. And list of index value is what? Value, this is the price. You can say weight. We have value. We can say pages, array. Then we store this C into H is H because C is equal to 1. Now we increase the power of C. So C become now 2. Now 9 minus 2 is equal to 7. Right? So C is 2. Then we have C into P, which is 2P and 2H. Now we will have 4P again, then 4H. Then at last we will remain with 3 copies. Then we have 3P because it will remain 3 bundle size will 4. This will break out the loop and we go for this. Whatever remains, the k value is 3 now. P is 3P and k into H is 3H. We have this. We broke those arrays, right? So this is how our this one loop of the item gone. Then we flatten. This is a flattened array, right? Then index is increasing, alright? So we bundle them in an array, and then we run the knapsack in this. So let me code this for you, right? In C++ we can code it. Alright. We were solving this problem here, right? So we have to upload this, right? Somehow. Okay, first we have to log in this. I have a account also here, guys. Don't worry. I don't do much questions, but I have accounts everywhere. So we have to submit it. How can we submit? Choose file. Is there any editorial here? We can choose language. We can highest level of language. We have to choose some file. Okay. So we have to do it in VS Code, right? Okay, so let me do it for you guys. let me share this also, guys. Can you see my screen, new screen, guys, now? Okay, so I will add one more view for you. Window capture, right? Yeah, I hope you can see it now. Let me see. Okay, so let me do that question for you. Cube, right? Okay, so what is the input format? Let me see what is the input format of the problem. We have this input format, right, guys? So this is the input format. The first line contains two integers n and x, a number of books and a maximum total price, right? So integer n, comma x we have, c in x here, guys, right? It's good, I think. I will put it like this, alright? The next line contains n integers, h1, h2, hn, the price of book. Plus we have to vector price of side n, guys, right? Alright, then we have next 1 times 0, I less than 1, plus we have price of I, right? Then next line we have what? N integers, pages, right? So we have to take another vector, pages of size n, then same copy, pages will be done here. We take pages, then next line contains n integers, the copies of it, alright? Alright, guys, so now we have these all arrays. Before all of this, we have to flatten it, right? So what we have to do, guys, is we have to take how many total copies are there, right? Okay. So before that, we can do it. We have to take two arrays. Guys, is like so before anything, we have to make a vector, right? Of final price, right? We have to make a vector of final weight, vector of final pages, right? Right. We have these vectors. Now what we will do, we bundle them all, right? So how we can bundle them? We have to pass each type of book into the bundle function, right? Okay, so we have for and this. We have to send the function. What is the integer? What is the price of this book? What is the number of pages of this book, right? And what is the price pages? One more thing was there, copies. For this book we have to send this in the function, right? Now this function, what it will do, it's a void function, right? Which takes integer of price, integer of pages, integer of copies, right? What it will do, it will bundle. It has we have index well, 0 here because yes, but what it will do, with the help of this code, we can Okay, we have price this and that. Okay, so we have a bundle size into bundle equal to 1, right? So while bundle is bundle is less than copies, then what we can do is we can reduce number of copies with the size of bundle, and after that after this okay, so bundle left, then we put this bundle into what we have a final price for this final class of index is equal to price into bundle size. We have final price of this bundle is index is equal to price into final price final pages index equal to pages into bundle, right? So we have updated the copies are updated, price pages are updated, and price also, right? So this will run after this. Then whatever the pages are left, what do we do with them? We have to update the index also, right? Index plus plus. Now at last, whatever the pages are left or the copies are left, then we update final price index is equal to price into copies, and final pages is index is equal to pages into copies, right? But one more thing, I think I am making mistake here. I am making mistake here is like I am taking this index because I have don't initialize this. I don't know the final size, right? So instead of accessing this like this, what I can do instead of index thing, I don't need to follow the index also. I have to do the pushback. I think I need to this. Then I need to do this now. Right. So I need to do this here. Okay. So this will run for all, and I can do this globally here, right? Also I can define these globally here. That's how we do, guys. Okay. So I think it's I have bundled them clearly, right? This is for bundle it. So now I have to run the nav0 and navsec on this, right? This. So which size I have to take now? Final copies now. Okay, final pages. Final price I can take. So now number of items we have. And n is equal to m is equal to final price dot size we have, and alright we have x amount. Now I have to define the vector of dp, right? So 0 1 navsec is there. I can only take the 1D dp here, guys, right? With the capacity of price, right? So vector of user dp x plus 1 comma 0 here, or 0 is less than m plus plus we are accessing each item, and is equal to x is greater than equal to okay, price should be price I j minus, right? We are following a tabular method here, and dp of j is equal to max of dp of j comma dp of j minus s of I plus pages of I. We can do this, and after that we can return price of x. No. dp of x, right? Alright, so I think this is the final solution we have. Or do we have to print it? I don't know. What is the output? Print only. So we have to print that. So see out this and return 0. this is how we do it, guys. I think it's right, but let's see if I am right or not. Let's go to this helper and check if it is right or not. Alright, what is the thing? Bug 1 is array mismatches. Look at your DP loops. You added I from 0 to m, size of your massive latent final price array. But inside the loop, you called price and pages. Alright, so this is the okay. So we can do that also. There is not a big issue. A small bug here. Final price. Final price, final pages. Okay. This is not a big problem. Okay, we have done this. Next, bug 2 is broken shrink wrapper. What is this? Inside your wrap function, you forgot to move straight to the line of the binary program. Okay, so we have followed this. The bundle size, because bundle always 1, you are just subtracting 1 from copies over and over again. Mathematically, you turn a light log case split into case split. Okay, so we forgot something, right, guys? We forgot this thing in our function, which is bundle is going to right 2 then 4 8 something. Okay, and the next bug is remember look at the F you push price but bundle represents the next size. Big. Alright, so we have to do the copies thing. Alright. So guys, this is the leftover copies we should. Right, guys? Is there any problem now? Is there any problem now? Is this let it check, then we upload it. There is only one micro optimization missing from leaving it out can accidentally trigger TLE. Alright, what is that? Phantom 0 bug. At the very end of a function, you have unconsciously added a leftover copy. Alright. What happens if the original quantity was exactly a power of 2 minus 1? Like this. Actually, reduce copies to exactly 0. If you push to that 0 array, you create a phantom item that costs 0, gives 0 value. When 0 loop and phantom, the additional j is then relates to j. Alright. And loop x times up to alright. Alright, this you have to do. If only copy is greater than 0, then I have to do it only. Alright, file is auto saved guys, yes, so hello. G57 14,000 बोलिए ना हैं सही चलाएगा नंबर हैं क्या है वो यार फिर बेक रहा होगा क्या करें वो कितने को बेगा EMI पे ले लो कैसे ले लो हैं 6,128 में है जन 8,128 में यार मोबाइल 8,128 में लगे देख के बताऊं हाँ देख तो भाई मेरे 8,128 में हैं रोटी क्या बताऊं हाँ महंगो है वो 17-18 को है वो हैं देख ले और कोई देख ले So yes guys, so what we are doing is yes, so we have a file, we can upload it now. Submit. We have to choose it from where we have a file. This okay. Submit it guys. So it's all accepted and it's the correct solution. It ran under the time and right. That's good guys. Very good here. And what we do is now we go to other problems. Right. Okay, right here. Another problem we have is knapsack 3 gear on DMOG. So let's practice with this. I have an account on DMOG also guys, don't worry. So DMOG allows without login also, right? Let me go for it. Do I have this? No. I have, but okay. If it is allowing after without this, then so Roger and George run a transport company here. One day their boss Victor tells them to transport some subset of the end goods to another warehouse. Roger observes. So now Roger observes that there are n I of ith items. Okay. each take of VI volumes in the truck and will give the profit of PI each. So it's like previous, similar to previous one, right? George is looking at the truck and observes that there are M of the trucks. Well, let trucks be a M, right? And I truck has capacity of CI, but will cost $5 for refueling. They must drive exactly one truck. Can you help them maximize their profit? Okay, so it's more complications now. So let's do this question first. This. Okay. Now we have Roger and Rosanna Transport Company. One day they both will tell them to transport some. One more thing here funny is Roger and George are the run means they are the boss, but they have also the boss. There is a law in the statement, guys. Hierarchy does not matching. One day their boss Victor tells them to transport some subset of N goods to another warehouse. Right? There are N goods. Roger observes that there are Ni of ith items. So we have Ni copies of each item I, taking up their VI volume. So VI volume and profit is PI here, right? Now George is looking at the trucks and observes that there are M of these trucks. George is looking at the trucks and observes that there are M of these trucks. We have M trucks, guys. And ith truck has the capacity of CI. CI capacity of ith truck will cost $5 of refueling. It will cost. There is a penalty, we can say. They must drive exactly one truck. Okay, so what the parameters here? If we are choosing the ith truck, it has capacity CI and it will cost FI. So reduce in profit. Reduction in profit. So can we take the DP array of what? 3D DP? Is this? I don't know, guys. Because we have a truck, we have a variable truck, right? With capacity and all. We have a variable cost. We have a variable of profit. Profit is not a variable, but profit is the what we have to find. We have a item, right? We have variable capacity. Capacity is also changing with each item. Alright, so So let's ask ChatGPT for this. If I can use 3D in this. Don't tell me the answer. Just tell me if I am correct or not. I will use 3D DP in this. Variables are capacity of the truck, right? Item, and we have capacity item. And truck number. So I am overthinking. You do not need 3DP for this. Including a specific truck as a variable in your DP state will overcomplicate the logic, likely cause you to run out of memory or time. The very close to the bolded constant in the image, they must driven exactly one truck. Alright. So if we are taking some truck, let's say one by one we can say, right? So because you are only never choosing one truck, you can completely decouple the truck from the item. Think about the problem in two completely different phases. Phase 1 is ignore the truck entirely at for a moment using the exact same bounded knapsack logic you just mastered. Then replacing how you can calculate maximum probability of any genetic volume capacity from 0 up to largest truck size. Right? Phase 2, once your 1DR is fully built and tell your max item profit for any volume. What simple operation can you do for M trucks list finalize? Okay, so right. So it's very simple, guys. There is no need to do many things in this. Correct? Which is the problem we are solving here on DMOG, right? DMOG is very favorite place for my because in our first semester, this is where we used to do these things. So what is the input here in this? Let me see. We can paste it here, we can paste it here, but first line contains two integers n and m. Okay. N and m, alright. Then what we have? Next n line contains three integers n, v or p. Alright. So we have three vectors 1, 2 and 3. Value of price, volume and price. Ni copies, right? So vi and pi, right? We have price, we have volume, guys. We have copy, we have volume, we have price. Volume. हाँ हाँ हम्म 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 तो अब उसका क्या करना है वो बोला अच्छा 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 हम्म 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 हम्म। ये क्या थे, 800 रुपये क्या थे फिर कल ये नहीं थी क्या? अच्छा तुझे भी नहीं, सही है। हम्म, अच्छा। समझ गया मैं, समझ गया, समझ गया मैं, समझ गया। हम्म हम्म, समझ गया। ठीक है, मैं आपको बेस्ट दिक्कत तो है नहीं, वो क्लियर होगी सब बात है। हाँ तो भर दे रहा हूँ, उसमें से 800 में से भर दे रहा हूँ, मैं बाकी का पे कर दूँगा। हम्म, हाँ हाँ हाँ। हम्म, हम्म, अच्छा। हम्म, वो तो है ही। सही है, सही है। ठीक है। हाँ हाँ, सही है, सही है। चल ठीक है फिर। Alright guys, so what we were doing is this, right? Okay, so this n line contains three integers n, v, p. N is the copies, v is the volume, pi is the uh, price, right? Profit we can say. We don't have to do this. Price. So we have a vector of price, we have vector of volume, we have vector of copies. So first it is giving copies, then it's giving us volume, then it's giving us price. Alright guys, okay. Volume also we can cut to the pages, because pages we are already there. Right guys, so now we don't need these two loops. Pages is we are creating volume here, and copies we have already know, price we already know, profit. Price is profit now, right? What we are earning from it. Now we bundling it with price, where we can profit, volume, and copies we have. After this we bundled it. Alright. So how we are bundling it? Bundle is size 1, copies. Price into bundle size, means profit into bundle size, and pages volume we are bundle. Alright, this is how this will remain same, right guys? This logic is same. We have bundled it. After bundle we have a final price size, means what? Final profit size, or we can say final. Alright, that is also there. Same. Now we have capacity, right, of each truck. Next M lines contains two integers Ci and Fi. So capacity and Fi is fine. So we need two vectors also now. Vector of integers, capacity, that is of m comma 0 here, a vector total integer. Fine, we are paying for zero. For n equal to 0 and capacity like a capacity we are I and we are paying fine for this, right? Okay, this is how we take the input. After this, for each capacity, for n equal to 0 less than m plus we define our city of I here, right? And for this capacity we are counting this. Right, guys? Right, so we are not outing it. And max profit to 0 here. After doing this loop, we check max prof is equal to max of max prof comma dB of x, or we can say capacity I. Right, guys? What we have to here, otherwise max profit reach city of I and let for I and which I is. We can use K here now, right? Alright, so this is the work of scope here. Whatever the scope is. Capacity of I. And clockwise. Alright, this is how we do it, guys. think it's good. Go good to guys. Let me ask our friend what is the problem in this. If there is no problem, we can upload it also. Now we can upload it as submit solution. Okay. Okay, I have to sign up for this. So, this was the username of my I have to find the new username. It's okay. The root language will be red. Password is too common, guys. What are you saying, bro? Use this strong password. Okay. Wait. What do I have to choose? Because you I am entering some random password, guys. Suggest some strong password. This is suggested password, right? Okay. Now I will okay, guys. So I have to Let me see, is there any? Okay, guys. So there are some errors I have made here. So let me, there is M here and there is M here. So let's take this as X, let's take X here. Right, whatever M is multiplied because it's working on this. This is X here, right? T minus Fi finite, right? Whatever the final. Okay, so I is I am using too much I here. Let's use K here. K here. K here. Right. Okay. So I think let's check this. Wait a minute. Wait a minute. are some errors, syntax errors, guys. I don't have time now because I am taking help from that. Okay, so I am late now. So batch 1 is only executed in this. This is a very hard problem, I think, guys. The wrong answer is query because I have only taken the max thing, right? So wrong answer, TL is not given because, so now I think I have to traverse through all the tracks, right? I don't need to take the max capacity and I will try exactly one track. In your previous code, you try your final answer tracker like this. Alright, the real scenario, imagine a title business day. Career. Alright. So we
उबंटू का पासवर्ड चाहिए।
सुनील उबंटू का
हाँ, कहाँ है तेरा रूम नंबर?
मेरा पीछे ही हो तेरे।
अच्छा, आ रहा है तेरे में?
अरे मेरे में दिक्कत क्या है ना, मैं अभी वो अमेज़न का हैकाथन है ना, उसका एक दे रहा था, तो उसके लिए स्मार्ट हायर ऐप यूज़ करना है, तो वो विंडोज़ में मैंने अपना ये कनेक्ट नहीं किया कॉलेज वाइज में, तो उबंटू में।
कॉलेज वाले से ही चलेगा वो।
हाँ
ले ले पासवर्ड, मुझे को देख के
अपना लिख के
अभी कुछ टाइम के लिए बंद मत करना।
नहीं, बंद नहीं, चालू करते हैं।
फोटो ले
कैपिट, हाँ फोटो ले लो।
ठीक है, थैंक्स।
कर भाई कर, टर्न ऑन कर दिया तेरा, कनेक्ट कर ले, बताइए कि नहीं होता।
हाँ हो जाएगा,
हो जाएगा।
आ रहा है मेरा पासवर्ड।
Okay, so this is the so I have to initialize with this minus 180, right? Okay, now all cases are passed, guys. Alright. Now we go to the next problem, which is knapsack 4. I will do this after my lunch. Thank you so much for listening. Let me stop the stream for now.